Welcome to a new test and teardown video. This time it's some DIY. Well, yeah, it is homemade home design, but for a company, by a company. So that is why the quality you're gonna see here is very, very high. It's a Data Collection Unit DCU Model 2. And you set it up for GMT time. We'll probably see the timing here, right? And it's data recording on a cassette tape. Not just any ordinary cassette, but a data cassette. And it's 300 minutes. Not 90 minutes, but 300. It even says here, let me show you, 800 bits per inch. So this is the maximum capacity you can put on this tape, and then you can multiply this by the length of this tape. So it's actually quite a lot of data. I'll get more into the detail about this Teac drive, because that Teac drive is very, very special. I don't want to stick down any kind of metal down here, by the way. But if you see here, this one is where you normally have this capstan kind of system. But here's made completely different. It's actually 3 active motors and a little opto detector here, where we'll see if there's tape in it. It's also very special due to this little, I don't know if we can see that. Can we? Yes, we can. This here. This prevents the use of normal cassette tapes because of that. And you can't even put it in the wrong way. There is only an A side. And this has something to do with the way that they're using the head. And the way that they're packing the data. So this cassette unit is a Teac MT-2 drive. And normally there's actually another module on the back of this drive, a data recording or storing and modulation board. I think it actually also contains microcontrollers and all that kind of stuff. That has been removed. And that means this is an analog interface where you just start and stop and input some tones, and then the tones will go to the tape for data recording. And you can see here the 2 motors here, and then the third one is of course that one, right? And this keeps the tape in perfect order, those 3 motors all together. So let's look a little bit inside this beautiful, beautiful, well-designed unit. This is of course made for data collection of some analog sensors. So we got some connectors here with analog inputs, and then we got DC supply inputs over here. And this is specially designed for the task. Here we got 8-bit DA converters. We got the 2 analog channels inputs. They go into 8 bits, so that's why we got those 8 bits. And they even space it so in 4 and 4. This is for easy reading of what is going on here and easy debugging. It's all made of CMOS logic. That will be some op amps. Look at the cabling and how it's soldered. This beautiful. This one is called digital minimums detector, and it's done by a person called PST in 87. And the board here in the middle, as you can see, this is the cable for the cassette deck. So I think all this is controlling the decks and start and stop and pulls this and pulls that. You can see all this, all those bits here. They go, of course, to all the digital stuff over there and so forth. It is an amazing design work, and it's just so beautifully made. I really like this. The gray wires, they just go all the way around the ICs like that. And the last module here, that is the timer, the clock module. So there's of course a high precision 8 megahertz temperature compensated super stable oscillator. And then all those counters and dividers and all that kind of stuff. That is the timing. And then we got 2 relays for 2 outputs here. So that is 1 pulse per hour and 1 pulse per day. Or was it 1 pulse per day and 1 pulse per year? I can't remember that. I will show you the rear side in a few minutes. So that will be the DC supply input, the blue ones, and then we got some regulators and all that kind of stuff. So this is the rear side of this Teac drive. This is the MT-2 version, not the MT-2 ST. That is a completely different product. And it is of course also possible to find data sheets and information about the MT-2, but when you find the information about that, it will all talk about this add-on board and the data interface and all that kind of stuff. If you remove the data interface and access this connector, it's of course a little bit you're a little bit on your own, because this is the analog interface. So that's the backside of the LCD displays for showing the time. And again, we got LCD drivers. Note all the BCD inputs for all the different drivers. It's amazing design. A 2-layer PCB, and all the PCBs in this one got no plating through. So everything here is soldered on both sides. And here is a hidden control panel. So there's actually a little, let me show you. So behind this one is a little hidden control panel. I think it's hidden like this because you don't want anybody to go and poke around with the settings. This is supposed to run for many, many days. So we've got days, hours, minutes, seconds, and all that kind of stuff. And this is a power for the tape deck. And if you power this and push forward, it's going to spin forward if you want to add a new position on the tape for your data recording. And what if there is a leap year? So this year you just click this one down for normal years or up for leap year. Or you can hold the time or you can reset the time. Those aluminium stickers with the text, that was super normal in the 80s and the 90s, because it's you use a film and then you UV light them and you develop them more or less like you develop your own PCBs. So it's the same kind of board, the light and films and all that kind of stuff. And then you can make really nice front plate designs. And this is the rear plate design. And that was the unused connector, probably for some future development. Channel 1 and channel 2, that will be some sort of an analog interface. I haven't figured that out yet, how that works. We got some communication, or I don't know what that is, maybe just some start-stop remote kind of stuff. 1 pulse per day, 1 pulse per hour, I guess, right? And we got a supply connector, and of course that is a different style of connector. So we got the normal 5-pin, and that is a little bit special 5-pin, depending on how they're spaced. So that means you can't plug this in wrong, but you can of course also just use the bananas like this. So here's what I will do. I will just plug 12 volt in like that, right? So that is the negative, and that will be the positive of my 2 cables, and then I will just power it up and show you how it works. So here is how it looks like. I just powered it on 7-8 seconds before I started this clip. I want to move the camera like this so we can see the tape as well. So it's just running like this, right? So we can just change. No, we cannot. Maybe we need to be. Why is this not working now? That was okay. Here we go. So now it's working. How do you explain that? So I hit minutes, and then I can now change the days, the hours, minutes, blah 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 blah, even the seconds, right? Yeah. And if I push hold, oh, okay. So you need to hold this. Oh, that's a little bit annoying. So that is how the clock is running. You're gonna be a little bit impressed about this design once again. You see how little power it consumes. And this is of course because everything is made in CMOS. Isn't that a little bit amazing? You did not expect to see that, did you? And it is made in '87. So this just reveals a little bit that we are dealing with a very skilled designer. Probably made this to run off batteries as well. Because this is, oh, that is very, very low power consumption, I must say. So how are we gonna make this record something on the data cassette here, right? I figured out it's gonna record a tiny little bit of data once an hour. So what if we set the minutes like this? Now look at this, the LEDs. I'll try and see if I can make the light. So the data cassette recorder should go on a little bit before the hour, and then it will spin the drive just for a very, very short time, storing a tiny little. So did you see its screen? Look at the deck. Look, look, look. Okay, that is it. That tiny, tiny little bit of data here is stored in 1500 ball in Manchester code. So just a few hundred bytes, and it just takes this quarter of a second to store the data, and now it's gonna run like this for an hour, collecting and adding and doing all sorts of fancy things, and then just continue to record like this. And then you can come back many hundreds of days later, collect your data, and do all sorts of a technical analysis on whatever you have recorded. So, I mean, that is really nice to use that little power for that many days instead of having PCs running. And I mean, PCs in '87, that was big and powerful stuff that was consuming hundreds of watts. So this is a very, very good way to do it. So this is the data, how it sounds, the data that they recorded back in the old days on this data cassette tape. Here's what I did. I took this data and I recorded it and I analyzed it, and then I figured out how it looks like. Let's try and zoom in a little bit. And then I looked carefully at the baud rate and the system here, and I figured out this is Manchester code, isn't it? And this is of course the Manchester code decoded, because this scope can of course decode Manchester. So this is the entire data package, and they repeat the content many times and only changes a little bit. I think this is the days and the time, minutes, and all that kind of stuff, and then the data that they are collecting. We can actually, yeah, okay, we could zoom in and look more careful at the start of the data. And then we can see how I've set up everything with the correct sync and all that kind of stuff. It's done using the protocol configuration. It's very important to have the baud rate. Oh, let me get a little bit closer here. The baud rate needs to be very, very accurate. 15, 20. That was the trick. Polarity and idle level, start edges, idle bits, blah, 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 blah. All kind of parameters I needed to adjust. And then I'll get all the data. I can show this in binary or decimal. It's just easier to read this in decimal format. And they all got the same header, and then I see different data from package to package. So it's definitely intelligent communication. Intelligent data is definitely stored on this cassette tape. So I think that is pretty cool, by the way. So this is the Teac MT-2 drive. This is exactly the right version we got, and look at the price. They gotta be on some sort of a pill, right? And just to complete this video about the data tape recorder, this is a much older version, and this is actually a very early prototype indeed. There isn't any text, there isn't any things, and the displays look a lot different. I don't know, where have you seen those types of displays before, right? Maybe it's inspired somewhere. Definitely a very early prototype. Of course, this was a discarded project, and you can even see somebody scored the rear plate from this one. So some of the cables are isolated with paper like that, just to make sure it's not shorting anything. Some really cool plastic wrap was put around this one, and then there wasn't space for all the PCBs, so they're now on top of each other like that. So they also improved on that design. I'm trying to find names or stickers or anything with names on it, but this one looks a lot like the same. So the timing unit That is more or less the same design as far as I can see. I took out the clock board, and I do find a lot of differences in the design, by the way. The clock oscillator here is now 5 megahertz. It's a special, look at that, offset plus minus 1 hertz. How about that? And then it is from 1980. So this is a quality trimmer. Look at that, huh? And that one go to the trimming of the oscillator. And if we look here at the back of the board, we can see this is called a digital clock Model 5, but it is from 1979. Also PST, I guess it says here. And then there's a modification done in 1980. So that means the initial design is from 1979. So this is definitely a very early prototype. So this is the cassette deck controller board, and it is wrapped in plastic. I mean, it's not good for static. I would have used an anti-static bag. But that is pretty cool. And as you can see, there are no wires soldered for external connections. So this is a brand new, fully ready and assembled board, but it was just never ever assembled. And again, this is from 1979. This is the data cassette recorder control, exactly as we thought. Manual layout and homemade PCB. And inside this paper wrap, I find the wire harness ready made. Look at that. Everything is completely ready, desoldered and ready to mount. Then it was decided not to go through with this model, I suppose. And that is the input board for the external data. I don't see any text written on this one. And again, you see early prototyping. But that's of course how development is. It's just real fun to see this. Yes, that will be all the outputs and good things. So this type of cassette deck is completely different. It is with a normal capstan, and there's this little rubber roll that goes and hold the tape like that. And the rear side of the tape is again very, very special. Maybe we can see what's going on here. All this electronics is of course gone because they only wanted to use this as their own analog recorder. They didn't want the digital interface. Oh, here we go. Made in Holland, type DCR4A. So that is maybe possible to look this up. Let's have a look about that. Well, that is definitely a nice motor. I also got another one, also of the first version, but here, as you see, there's a display missing. We will see the data or the analog levels or the input from channel 1 and 2. And again, all the days, hours, minutes and seconds and all that kind of stuff is the same. The control panel, that was also the same. So I bet this one is also from 1980 or maybe a little bit later, because now we got the labels and everything here on it. And here is actually a little bit interesting. Digital clock day. So that is the day codes. What the? So 1st December. And then you put this day code. This is the day number. Oh, okay, that is the day number of the year. So that is how it works. So with this information, I should of course be able to decode the data from the tape. And this way I can tell exactly how old the data was in that year, but I don't know what year. Maybe we should try and look inside this one and see if it's any better. They tried to add some paint on the digits and that seems to have failed. But of course it's 40 some years ago, right? And yes, this one is very much complete. Analog inputs, the same outputs here. This one runs off a single 12-volt supply. Got a nice regulator here. It's a little bit corroded. So this one was a little bit outside in the rain, as far as I can see. It's also quite visible on the inside of connectors and stuff. But this one is complete. We got all the parts, and again I see different versions of everything. All the LED resistors, LED drivers, see, B, C, D, all that. Oh, this is nice. So this is definitely next version of this project. Also 5 megahertz and some really nice relays. Those are super high quality relays for the 2 digital signal outputs. The drive is again this DCR4A from Holland, and now they have interfaced to it, and then there's a cable going to that module again, and the input board from the 2 sensors. Maybe we should look a little bit more in detail here. I've been looking a little bit on this AD converter. It's actually called A-min to digital converter, and it's from 1979. That's a very impressive design, by the way. If you look at the part numbers here, so we got analog conversion and output driving and all that kind of funny stuff here. It's op amps and analog input here, right? But I see something that is really funny up here. So we got an oscillator and a push-pull driver, and this is driving negative supply to a negative 5 volt for the op amps and stuff. So that is how it's done, so it can run off a single-ended 12 volt input. That's actually pretty cool. That is a nice voltage reference, right? Yeah, okay, this is of course expensive, so it's reused in the other channel, of course. And then all the digital outputs here in BCD format goes to all the BCD drivers down here, and that will let us read the value of the two inputs. It's really sad to see all the corrosion all over the place here. We see it's there was a little bit of acid damages now and then, but it's actually really bad here with the higher voltages. But those two are connected to the same point, right? But here it's not so good. But if I only power this up for a short period of time, and then it's most likely going to be alright to see if it is alive. How about we do that? So I might as well just start the video and turn on the power. But I see nothing. Ew! It's reacting to... Oh! It's my fault. Display is running. Oh, so that is a half an amp. And now the display is not running. It's 60 milliamps. Okay, so that is the thing. So how do we make... That will be the days. Oh, let's turn off this. Still real bad, isn't it? Hours, minutes, seconds. Ah, that display is the... Oi, oi, oi. I really want to connect something on the analog input. How about we just start with a dummy load, so at least the input is not floating. Yeah, man. Then it got... Oh, that 80 converter is working. I want to put in some voltage and see what happens. That is so cool. It actually turns out that it is not... The inputs, they're not responding to any of my analog inputs, at least. So maybe maybe I need to put in some AC or whatever I need to do. It's just random numbers that just happens like this. Sometimes it stops, and I haven't really yet figured out how exactly that works. I'm also trying to make here an hour. Trying to hear if there's anything going on with the... Yes, did you hear that? I heard it. It went like... So it actually started the motor just for half a second, just like the later models they do. And it actually activates the DCR like that. So if you crank this on and off, sometimes it will... I don't understand when it's doing this. Here, now it did it. Maybe it's supposed to do like that. So there's a big solenoid that goes in and out here that will activate the tape, something like that, and then it will... You can hear. Okay, let me show you. When I hit the forward button, the motor goes. But anyway, that was some pretty amazing data collection units from the 1980 using cassette tapes. Isn't that just lovely? Now you have seen that too. Please come back for more. Bye bye.